So in last class, we have seen so what is Cauchy-Riemann equations in Cartesian forms, right? Here, that means in today's lecture, we will go with the polar form of a CR equations. So what is polar form and some problems, and then what is harmonic function and how to find harmonic conjugate of some given either real or imaginary part. So that concepts we discussed today, right? Now, so already we know that the CR equations in Cartesian form, that is dou u by dou x is equal to dou v by dou y, and dou u by dou y is equal to minus dou v by dou x, right? So here, so polar form, na? Polar form of CR equations. See, so our statement. So let f of z be any complex function. So f of z be any complex function. So which is equal to f of r e power I theta. So which is polar, right? So f of z equal to f of r e power I theta. So this can be written as u of r comma theta plus I v of r comma theta, right? So this is real part and it is imaginary part. So this is your complex function, right? And f of z is differentiable. So differentiable at z naught equal to r naught e power I theta naught. So this is also differentiable. Then f of z is analytic if it satisfies dou u by dou r is equal to 1 by r dou v by dou theta. So dou v by dou r equal to minus 1 by r dou u by dou theta, right? Now coming to so these equations are called CR equations, Cauchy-Riemann equations in polar form. In polar form. So whereas in Cartesian form, dou u by dou x is equal to dou v by dou y, and dou u by dou y is equal to minus of dou v by dou x, right? So this is in polar form. So already we know the polar form. So which is suppose so this is x, so this is y, right? So this is your complex number z, so then it is this is your modulus of a complex number. So modulus of a complex number. So right here we polar form is x equal to r cos theta. So r is nothing but square root of x square plus y square, it's a modulus, right? So y equal to r sin theta. So this comes from, so see, if you take this as, so this is your angle theta, right? So this is your angle theta. So now from this, so this is r na, right? So from this cos theta equal to, see, cos theta equal to cos theta is adjacent side by hypotenuse, right? Adjacent side by hypotenuse. See, so this is your x, so this is your y, right? Now adjacent side, this is your adjacent side x by, so your hypotenuse is r. So from this it is x equal to r cos theta, right? It is clear. Now similarly for sin theta, na, sin theta equal to opposite side by hypotenuse. Opposite side is y by hypotenuse is r. So then it is y equal to r sin theta, right? So this is your polar form, and x square plus y square is always r square. See, x is nothing but r cos theta, y is nothing but r sin theta, x square plus y square is r square, right? It's clear. So this is your polar. See, your Z is R e power I theta. So how this come is, generally we have Z equal to X plus I y na. Z equal to X plus I y na. Now, in polar form, so X is R cos theta plus I into Y is R sin theta. Right? It is clear. So then taking R common, it is cos theta plus I sin theta. So which is equal to R e power I theta. Right? So this is your Z. Now it is okay. Now f dash sub z is, what is f dash sub z, right? Or dou by dou r of f of z, it clearly. So it is, see, now you are partially differentiating with respect to r. So that means it is f dash of z into dou by dou r of z, right? It is clear. So which is f dash of z into see, dou by dou r of, so your z is nothing but r e power I theta, r e power I theta, right? Now see, so this is equal to f of z, f dash of z into, now dou by with respect to r means, so your theta is constant, right? E power I theta. Now dou by dou r of r, so that means it is a dou by dou x of x. Dou by dou x of x is 1, so therefore it is 1. So from this it is clear that f dash of z equal to, right? F dash of z equal to, so e power I theta 1 by e power I theta into dou f by dou r, right? Now similarly you do with the dou by dou theta of f of z. So what is dou by dou theta? So which is f dash of z into dou by dou theta of z, right? So which is equal to f dash of z into, so dou by dou theta of r e power I theta. So your z is r e power I theta. So which is equal to, now f dash of z into, so with respect to theta na, it is r. So e power I theta is e power I theta into I, right? So r into e power I theta. Now it's dou by dou theta of e power I theta is e power I theta. Again you have to do dou by dou theta of I theta. So for that it is I. So now from this it is clear that f is 1 by r e power I theta. So with the I, right? Now dou f by dou theta. Now so this is 1, this is 2, right? Now see, dou f by dou r. See, we have f equal to, I mean f of z equal to u of r comma theta plus I v of r comma theta, right? Now dou f by dou r, which is dou u by dou r plus I v dou v by dou r with respect to r. Now see, similarly dou f by dou theta equal to dou u by dou theta plus I times of dou u by dou theta. It is clear? Are you following? Hello? Is it okay? If there is any problem, please raise. Otherwise, I will continue. Is my screen is visible? Hello?
Yes, sir.
Right. Now from 1, see, f dash of z. So f dash of z equal to 1 by e power I theta. So dou f by dou r na. So dou f by dou r, you replace it by dou u by dou r plus I times of dou v by dou r. Right? So this is your f dash. Now from 2. So from 2, f dash of z equal to, see, which is equal to 1 by r I e power I theta. So it is dou f by dou theta na. So dou f by dou theta is dou u by dou theta plus I times of dou v by dou theta. Right? So these two are equal na. So then you equal it. You equal it. So what you get is 3. 8. So if you equal 1 by e power I theta dou u by dou r plus I times of dou v by dou r is equal to 1 by r I e power I theta dou u by dou theta plus I times of dou v by dou theta. Right? Now e power I theta, so here is e power I theta get cancelled. So then what is remaining? Dou u by dou r plus I times of dou v by dou r is equal to 1 by r. Now see here 1 by I na. So 1 by I can be written as I by I, right? Dou u by dou theta plus dou v by dou theta. Now which is equal to 1 by r into, so see I by, so denominator I square is minus 1. So it is nothing but minus I, right? Now it is dou u by dou theta plus I times of dou v by dou theta, right? Now you multiply. So that means it is minus 1 by r dou u by dou theta I, right? It is clear? Now we multiply with minus I. So then it is 1 by r into, see, minus of I square. Minus of I square is nothing but minus of minus 1. It is 1, right? Dou v by dou theta, right? So here is dou u by dou r. So plus I times of dou v by dou r, right? Now you compare with the real and imaginary part. So here it is real, right? It's a real part. So here it is a real part, right? From this you write. So from this you write dou u by dou r is equal to 1 by r dou v by dou theta, right? So this is one of the Riemann equation, Cauchy-Riemann equation. Now see, imaginary part, dou v by dou r is equal to minus 1 by r dou u by dou theta. So this is second Cauchy-Riemann equation. These two are called Cauchy-Riemann equations in polar form. Cauchy-Riemann equations in polar form, right? So whereas in Cartesian form, dou u by dou x is equal to dou v by dou y, and dou u by dou y equal to minus dou v by dou x. Is it clear? Right. Now see, if I take a simple problem. Show that f of z equal to z power n is analytic for all z. Analytic for all z. So f of z equal to z power n is analytic for all z. So how we do this? For suppose f of z equal to z square. Suppose f of z equal to z square. How we check the function is analytic? If you consider f of z equal to z square, then how you prove the function is analytic? Hello, can someone speak? If f of z equal to z square, how you prove f of z is analytic?
So I'm splitting z square equal to x plus 5y whole square, sir. Then u is equal to x square minus y square and b is equal to 2xy.
Right.
Then dou u by dou x and Cauchy-Riemann equation.
That means we are using Cauchy-Riemann equations in Cartesian form, right? See, for suppose if we take z x plus iy, it is clear to separate real and imaginary part. For suppose z square x plus iy whole square, it is easy to separate real and imaginary part. Suppose z power 3, so of course a plus b whole cube formula you know. So then you separate real and imaginary. Okay. So then that means x plus iy whole power 4, x plus iy whole power 5. So it is difficult to prove. It is difficult to check the analytic using Cartesian form, right? So that we are using polar form. See, simply, so what is z? Z is nothing but r e power I theta. In polar form it is, right? So then your f of z is, see, f of z equal to r e power I theta whole power n, right? It is clear. So which is equal to, see, r power n into e power I theta whole power n. Okay. So then a power m whole power n formula it is. So that means e power I n theta. A power m whole power n is a power mn, right? So then what is e power I theta? Cos theta plus I sin theta. So cos theta plus I sin theta. It is clear. So which is equal to r power n into cos n theta plus I sin n theta. Right? Now you separate. So which is r power n cos n theta plus I into r power n sin n theta. Right? So this is f of z. So f of z is nothing but u of r comma theta plus I v of r comma theta. Right? Which is equal to r power n cos n theta plus I times of r power n sin n theta. Right? And now what is real part? So which is u equal to r power n cos n theta. Now what is v? R power n sin n theta. Right? So then, so what is CR equations means? Dou u by dou r equal to 1 by r, dou v by dou theta, right? Right. Now dou u by dou r you need. Dou u by dou r, which is nothing but dou by dou r of r power n cos n theta. See, so with respect to r we are doing, that means cos n theta is treating constant, right? Now dou by dou r of r power n. So which is equal to cos n theta. Cos n theta. Now dou by dou r of r power n, n into r power n minus 1. So dou by dou x of x power n formula, right? It is clear. So which is n r power n minus 1 cos n theta, right? Now what is dou v by dou r? So which is equal to dou by dou r of r power n sin n theta, right? So which is sin n theta is outside. Now dou by dou r of it is r power n, right? So which is equal to sin n theta. Now dou by dou r of r power n is n into r power n minus 1, right? So then all right. Now dou u by dou theta. So which is equal to dou by dou theta of r power n cos n theta, right? So which is equal to r power n, treating it is constant. So then dou by dou theta of cos n theta, right? So which is equal to r power n, dou by dou theta of cos n theta is minus sin n theta into again dou by dou theta of n theta. So which is nothing but n, right? So which is minus n r power n sin n theta. Right? It is clear. Then it is dou v by dou theta. So which is equal to dou by dou theta of, here is r power n sin n theta, right? Which is equal to, see, r power n is treating it as constant, then it is dou by dou theta of sin n theta, right? So dou by dou theta of sin n theta is cos n theta into again dou by dou theta of n theta. Dou by dou theta of n theta is n, so which is equal to n r power n cos theta, cos n theta, cos n theta. So it is okay, right? See, what is dou u by dou r? So you are getting n r power n minus 1 cos n theta, right? Which can be written as n into r power n into r power minus 1 cos n theta, right? Now if you multiply by r, so then it is r, okay, leave it. Dou u by dou r equal to, see, dou u by dou r equal to what you get, n r power n r minus 1. So which is equal to, see, dou u by dou r equal to dou u by dou theta. So just you check it. Dou u by dou theta is this, right? So that means n r power n cos n theta, you write it as dou v by dou theta. So into remaining is r power minus 1. So which is equal to 1 by r dou v by dou theta, right? Now dou u by dou r is equal to 1 by r dou v by dou theta, right? Right, it is clear. Then similarly, dou v by dou r. So what dou v by dou r? So it is what is dou v by dou r? Dou v by dou r is sin n theta n into r power n minus 1. Dou v by dou r is n into r power n minus 1 sin n theta, right? So similarly, n into r power n into r power minus 1 sin n theta, you write sin n theta, right? So see, no, r power n r power n sin theta, n r power n sin theta, you write it as minus dou u by dou theta into r power minus 1, right? It is clear, it is minus 1 by r dou u by dou theta, right? Now you check, dou u by dou r equal to 1 by r dou u by dou theta, dou u by dou r equal to minus 1 by r dou u by dou theta. So CR equations are satisfied. U and V satisfied CR equations, right? CR equations. So therefore we say that f of z equal to z power n is analytic for all z, analytic for all z, right? It is clear. So similarly you go with the many problems. Someone are asking about joining. Let us see our next problem. So next problem. So prove that dou square by dou x square plus dou square by dou y square of real f of z whole square, so which is equal to 2 times of mod f dash of z whole square. So this you need to prove. See in this, so the terms. So what are the terms? Wait. Right. See, the terms are, so what is real f of z? What is real f of z? So what is f dash of z? Right? What is real f of z? See, so your f of z is u of x comma y plus I v of x comma y. Right? So that is nothing but u plus iv. Right? So in this, so what is real of f of z? Real of f of z is nothing but real part of f of z. Real part of f of z. So what is real part of f of z?
U, sir.
U, right? Real of f of z. So real of z is u. So it is clear, right? Next term you need f dash of z. See, so it is dependent on two variables, right? Either with respect to x or with respect to y. Suppose if we take with respect to x, dou u by dou x plus I times of dou v by dou x, right? So this is your derivative f dash of z, right? It is clear. Then see, so we have a Cauchy-Riemann equations, right? Dou u by dou x is equal to dou v by dou y. See, dou v by dou x is equal to minus dou u by dou y. It is clear. So now I am replacing CR equations. Dou u by dou x is equal to dou v by dou y. So I just replace the dou u by dou x is equal to dou v by dou y. Dou u by dou x equal to minus dou u by dou y. So otherwise, same. So like this form, dou v by dou x plus I dou v by dou u by dou y plus dou v by dou y. This is also okay. So that means your f of z is u plus iv. Then f dash of z is, suppose with respect to x means dou u by dou x plus I dou u by dou x. You can use Cauchy-Riemann. Dou u by dou x is dou u by dou y. Dou u by dou x is minus dou u by dou y. So you can use that, or with respect to y means dou u by dou y plus I dou u by dou y. So this is your f dash of z. Right? It is clear. It is clear. No problem. If you have any doubts, ask now itself. No problem. So this is class, not interview, etc. If you have any doubts, ask now itself. Right? Now, so what is real of f of z? What is f dash of z? Now, okay. Right. Now, what is modulus of a complex number? See, modulus of a complex number. Modulus of f of z is square root of u square plus v square, right? So it's real part, it's imaginary part. So that means see, modulus of real f of z na. See, real f of z is u. That means modulus of u whole square, right? So which can be written as modulus of u plus 0I whole square, right? So which is nothing but u square. Okay. So that means modulus of real of f of z is u square, right? So similarly, modulus of f of z whole square na. See, f dash of z is this f dash of z na. So dou u by dou x whole square plus dou u by dou x whole square రాసుకోవచ్చు. Otherwise, dou u by dou y whole square plus minus of dou u by dou y whole square రాసుకోవచ్చు. Right? Different forms are రాసుకోవచ్చు. But at the last, what point we need that you have to add. That's all. Right? Now, I'm considering LHS part. What is LHS part? So what is LHS part? Now what is LHS? So dou square by dou x square plus dou square by dou y square of real f of z whole square. This you need, right? Is clear? So it is equal to, see, dou square by dou x square plus dou square by dou y square of modulus of real f of z na, so which is u square, right? So which is equal to dou square by dou x square of u square plus dou square by dou y square of u square, right? See, now you consider dou by dou x of u. So u is nothing but xy, right? So which is equal to so which is dou u by dou x, right? U square kada, right? Right. Dou by dou x of u square, so which is equal to 2u again dou u by dou x. Like it is clear. So dou by dou x of f of x whole power n is n into f of x whole power n minus 1 into mal again f dash of x, right? It is okay. Then see, dou square by, that means dou square by dou x square of u square na. So which is equal to dou by dou x of again dou by dou x of u square na. So which is dou by dou x of dou by dou x we are already found. So which is dou u by dou x. Now which is equal to, this is of the form uv, right? 2u into dou square u by dou x square plus 2 dou u by dou x into again dou u by dou x, right? It is clear. So that means right, we write this like as dou by dou x square of u square, so which is equal to 2 you can take common u dou square u by dou x square plus dou u by dou x whole square, right? Right. Now similarly, dou square by dou y square of u square you need. See, with respect to x means this is, right? With respect to y means we can write it is u dou square u by dou y square plus dou u by dou y whole square, right? Now we need to add, so that means if adding these two, you get dou square by dou x square of u square plus dou square by dou y square of u square So which is equal to 2 times of uh, uh, no, 2 times of 2 if you take common. So then here is see, these two are added. So that means you again take common, dou square u by dou x square plus dou square u by dou y square, right? Plus dou u by dou x whole square plus dou u by dou y whole square, right? So which is equal to c. See. So this we call Laplace equation. So Laplace equation is nothing but del square u. So that means it is dou square u by dou x square plus dou square u by dou y square is always 0. So which is called Laplace equation. So what is Laplace equation means? Dou square u by dou x square plus dou square u by dou y square equal to 0. So that is your Laplace equation, right? So therefore you get, so what you get, dou square by dou x square plus dou square by dou y square of u square is equal to, see this is, if this is 0, then what you get, 2 times of dou u by dou x whole square plus dou u by dou y whole square. See, here is our f dash of z is dou u by dou y plus I dou u by dou y, or dou u by dou x plus I times of dou u by dou x, right? Right? This is dou square by dou x square plus dou square by dou y square of u square is, u is nothing but real f of z with modulus square. So this is our important problem, right? Now second one, see, so similar problem. So prove that dou square by dou x square plus dou square by dou y square, so which is equal to 4 times of dou square by dou z bar. See what is dou square by dou x square plus dou square by dou y square, which is equal to 4 times of dou square by dou z bar. See, z bar is nothing but conjugate, that means x minus iy, right? See, here is actually the problem, how it is means, see the problem how it look like is dou square by dou x square plus dou square by dou y square of f. F means f of z, which is equal to 4 into dou square by dou z bar f of z. So the problem looks like this, right? Now what is f of z, you know already know, right? Or here, so what is see, this can be written as 4 times of dou square means dou f by dou z into dou f by dou z bar. So because see, this z and z bar are independent, those are not same. So we say that otherwise మీకు ఎలా చెప్పాలంటే చూడండి, see dou square f by dou x square means we can write dou by dou x of dou f by dou x, right? It is clear. See, so these are same means therefore we can write dou square f by dou x square. See, dou square f by dou x dou y means you write dou by dou x of dou f by dou y, right? So this means these two are unequal, therefore we write dou f by dou x into dou f by dou y. So that means dou f by dou z into dou f by dou z bar, right? Now see, what is z? So what is z? X plus iy. Now what is z bar, so which is x minus iy, right? So z is nothing but x plus iy, so z conjugate is nothing but x minus iy, right? Now if we add, so what you get if you add minus iy plus iy get cancel, it is 2x, right? 2x equal to z plus z bar, right? So then x equal to z plus z bar by 2, right? It is clear. All right. Similarly, see z minus z bar, z minus z bar. See, x minus x get cancelled. It is 2iy, right? So then you write y equal to 1 by 2i z minus z bar, right? It is clear. Now see. So what is dou x by dou z, right? So what is dou x by dou z bar? So here is what is dou y by dou z, dou y by dou z bar. See here is dou x by dou z na. So with respect to z, dou x by dou z, 1 by 2 times of dou by dou z of this means 1 plus dou by dou z of z conjugate is treat z conjugate as constant. Therefore it is 1 by 2. So similarly this is also 1 by 2. See here 1 by 2 I. So dou by dou z of z is 1, right? See here is minus 1 by 2 I. Right? It is clear. Dou x by dou z, dou y by dou z, dou x by dou z bar, dou y by dou z bar. So then, so what you need dou f by dou z. Dou f by dou z you need to calculate. So by chain rule we can write dou f by dou x into dou x by dou z, right? It is clear. Dou f by dou y into dou y by dou z, right? So already everyone knows chain rule, right? Dou f by dou z can be written as dou f by dou x by dou z, right? It is clear, right? Now what is dou f by dou x? It is not dou f by dou x, right? Now dou x by dou z, so which is nothing but 1 by 2 plus dou f by dou y, okay? Now dou f by dou z is, it is 1 by 2i, right? See here 2 to same na? So then take LCM, right? So it is 2 dou f by dou z equal to dou f by dou x plus 1 by I na. 1 by I is nothing but minus I, right? Minus I into dou f by dou y, right? So it is nothing but dou f by dou x minus I into dou f by dou y. So it is dou 2 times of dou f by dou z, right? It is clear. So then similarly, so what is 2 dou f by dou z conjugate? Z conjugate na, replace I by minus I, that's all. Dou f by dou x plus I times of dou f by dou y. It is clear. So it's because it is a conjugate, replace I by minus I. Replace I by minus I. So then you so what you need is you multiply these two. So 2 into 2, 4. It is dou f by dou z into dou f by dou z conjugate. So which is equal to, if you multiply these two, see a plus a minus b into a plus b na. So then it is nothing but a square. A square is dou square by dou x square plus dou square. See it is minus I whole square now. See dou square by dou y square. It is minus I whole square, right? Minus I whole square is I square. It is minus 1, right? Our formula is a minus b whole, a square minus b square, right? Here is minus. So then here minus I whole square is I square. I square is minus 1. Here minus and minus plus it cancel. I mean plus it is minus and minus is, it is plus. Dou square by dou y square into f, right? Here is 4 into dou square by dou z bar into f, right? So this f get cancelled. This is our result. See, before finding or before proving, so the terms you have to know. So what are the terms? So if you know the terms and if you know the differentiation, so then easily you get answers. The next one, prove that dou square by dou x square plus dou square by dou y square modulus of f of z whole square, so which is equal to 4 times of f of z whole square. See, now from above, dou square by dou x square plus dou square by dou y square of f is 4 times of dou square f by dou z bar, right? It is clear. See, these two are same, right? Since, I'll take another. See, since dou square by dou x square plus dou square by dou y square of f is equal to 4 times of dou square by dou z bar, right? It is clear from the above, right? Then see, it is compared with the this. So your f is nothing but, so your f is mod f of z whole square, mod f of z whole square, right? Okay. See, since modulus of z whole square is equal to z into z conjugate, so this is our property. So modulus of z whole square is equal to z into z conjugate, right? Or you can check z equal to x plus iy, z conjugate equal to x minus iy. So then if you multiply z into z conjugate is a plus b into a minus b, a square minus b square, right? So it is nothing but x square plus y square. It is nothing but modulus of z whole square, right? So similarly you write modulus of f of z whole square, so which is equal to f of z into f of its conjugate, right? Okay, is it clear? Now you compare with the above, so which is equal to, I mean, dou square by dou x square plus dou square by dou y square of f equal to 4 times of, so that means dou square by dou x square plus dou square by dou y square of f is equal to 4 times of dou square by dou z bar, right? Now it is 4 by 4 into, okay, dou by dou z bar of, so your f is nothing but here is f of z into f of z conjugate, right? Now it is clear. So which is equal to 4 into, see, dou by dou z of, so with respect to this, so that means f of z is outside, right? So with respect to z conjugate we are doing, f of z is outside, so that means it is f dash of z conjugate into f of z, right? So which is equal to 4 times of, now with respect to z, means its conjugate is constant, that means f dash of z, right, into dou by dou z of f of z, right? It is clear. So which is equal to 4 times of f dash of z conjugate into Dou by dou z of f of z is f dash sub z. See, it is from this it is so f dash sub z into its conjugate, right? So we can write 4 into modulus of f dash sub z whole square. So because modulus of z square equal to z into its conjugate. So it is f dash sub z into its conjugate. So therefore you write 4 into f dash sub z whole square, right? Right. Okay, right. Similarly, show that dou square by dou x square plus dou square by dou y square of log mod f dash sub z equal to 0, right? See, same formula you use dou square by dou x square plus dou square by dou y square of f is equal to 4 times of dou square by dou z conjugate of f. F is nothing but log of f dash sub z square, right? So which is equal to 4 times of dou by dou z of first conjugate repeating dou by dou z of log f dash sub z, right? All right. Now come. Now what is dou by dou z of log f dash sub z? Are you following? Now see, can someone? What is dou by dou z of log f dash sub z? Hello. So what is dou by dou z of log f dash sub z? So which is 1 by f dash sub z into again f double dash sub z, right? Now see, you have to differentiate with respect to z conjugate, but it is a function of z only, right? So therefore it is 0. It is clear. Is it okay? Hello. Now coming to our next topic, harmonic function. See, an analytic function f of z is said to be harmonic if it satisfies Laplace equation. Laplace equation, that is nothing but dou square u by dou x square plus dou square u by dou y square equal to 0. See, any function which satisfies Laplace equation, so which is called harmonic function, right? See, if f of z is analytic, then if f of z is analytic, then we say that v is an harmonic conjugate of v, u. So if f of z is analytic, then we say that v is a harmonic conjugate of u, right? So for suppose if we take a real part, u is x square. U is x square. So then what is dou u by dou x? So what is dou u by dou x is 2x, right? What is dou square u by dou x square, which is 2, right? So what is dou u by dou y, which is 0? Dou u by dou y square, dou square u by dou y square, which is 0. Then if you add, you get 2 not equal to 0. Therefore, u is not harmonic. U is not harmonic function. Okay. Is it clear? Next one, see. Sorry. U equal to x square minus y square. U equal to x square minus y square. Can someone check whether U satisfies whether U is harmonic or not? So that means you have to find dou u by dou x. So what is dou u by dou x? What is dou u by dou y? What is dou v by dou x? I mean, sorry. Right, it is clear. Dou square u by dou x square, dou square u by dou y square. Then what is dou square u by dou x square plus dou square u by dou y square? If it is 0, then we say that it is harmonic.
Sir, dou square u by dou x square plus dou square u by dou y square equal to 0.
0. So because what is dou u by dou x? Dou u by dou
2x,
x.
sir.
It
2x.
is dou u by dou y
2x, sir. Minus 2y.
minus 2y. So here dou square u by dou x square is
Minus 2y. 2, sir.
2. Here it is minus 2.
2.
If you add this, you get 0. So therefore, u is harmonic function. F of z is harmonic function. So then you can calculate harmonic conjugate. Right? So next one. Next problem, see. So u is nothing but 2xy for suppose. U is 2xy. So then dou u by dou x is 2y. Dou u by dou y is 2x. Then what is dou square u by dou x square? So which is 0. What is dou square u by dou y square? Which is 0. Right? So then we say that dou square u by dou x square plus dou square u by dou y square is 0. So we say that the function is harmonic function. The function is harmonic function. Is it clear? Hello? Yes.
Yes, sir.
Yes, sir.
Okay. So then we go for it. If it is harmonic, then find V. So our next process is, if U is given, so then U satisfies harmonic function. So then what is harmonic conjugate? Or if V is given, then V should satisfy harmonic function. Then what is U? So our next process is this. That means in next class we will do. So what is harmonic conjugates? Right? So in this, so CR equations are very important. So in the, with their problems, right? So polar form. So then first inequality is very important. So what is dou square u by dou x square plus dou square by dou x square plus dou square by dou y square of modulus of f dash of z whole square, which is equal to 4 times. That is very important, right? So these are definitions. So what is harmonic function? If it is harmonic, then we say V is a harmonic conjugate of U if f of z is u plus iv. If f of z is u plus iv, if u is harmonic function, then V is said to be harmonic conjugate of U. Right? See, so one thing, both are not harmonic conjugates. That means U is a harmonic conjugate of V, then V is a harmonic conjugate of V. So that's not satisfied. If U is harmonic, V is harmonic conjugate. If V is harmonic, then U is harmonic conjugate. That you should know. So f of z is U plus IV. Right? If U is harmonic conjugate of V, otherwise V is harmonic conjugate of U, but not both. That you should remember. Okay. Right.